Uh, Hi, Jashna. So, may I know about you, whether you are from IT background or non-IT?
Me, I am
Yeah.
from an IT background. I worked as an automation test engineer for 1 year at Cognizant.
Okay.
Then
Okay.
I came for masters.
Okay. 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 So you have
Mm.
idea, right, regarding IT, how the
Yeah,
things
yes,
happen
yes, I
in
do.
IT.
Yeah,
Mm.
I do have.
Okay. So any idea on the DevOps?
Not much idea, but I have been like seeing how does that work, DevOps with ATS, what are all technologies included. So I have been working on that one, but I don't have like uh full
Okay.
knowledge on how that
Okay.
works.
Okay.
Yeah.
Okay. No issues. So the course is DevOps with AWS. Okay. So we are going to deal AWS Cloud and DevOps tools. That is the course, and this course is for 2 months. Now
Okay.
around 45 classes of course duration. Okay, so 45 classes will get around 2 plus months. Okay, and
Okay.
today we'll discuss just what are the contents from DevOps point of view. What tools we are
Mhm.
going to discuss. That discussion will see today. And as you already have idea on IT, I think no need to go about the SDLC. You know SDLC, right?
Yeah,
So
yeah, I do. I still
yeah,
see.
yeah, software development life cycle. We have
Software
different
development. Yeah.
yeah, different types of SDLC methods, right? So no need to go through the
Yes.
SDLC method because
No, no,
we
no.
already
Mm.
yeah. Just we'll see how the DevOps tools will work in SDLC. Okay, so in which phase, what tools we are going to use from the DevOps tools. Okay, so that thing will see today's class. Okay,
Okay.
and
Yeah.
I will have some brief idea introduction about the cloud computing. Okay,
Okay.
so
Yes.
any idea on cloud computing?
No, I don't have any idea on cloud computing at all.
Okay, okay, okay. No issues, no issues. We'll start from the basics. Every tool, not only AWS, every tool will start from the basics and we'll cover up to the advanced topics.
Okay. Yes.
So, so coming to the course content here, from DevOps point of view, we are going to uh, deal the different tools like um, Jenkins, Docker, Kubernetes, Ansible, Terraform, then we'll go with the AWS. Okay, so these are the tools we are going to cover in our 2 months of duration. So
Okay.
here, every tool will have its own purposes throughout the SDLC. In SDLC, you will have different phases. Okay, so in every
Mm.
phase, we are going to use one tool here. So Git we are using in one phase. Jenkins we are using in one phase. Okay, so Docker we are using in another phase like this. Okay, now so
Okay.
to work as a DevOps engineer, uh, there is no prerequisite, but we need Linux basics.
Mm.
Basics of Linux is sufficient. Okay. So any
Okay.
idea on Linux?
Yeah, yeah. I've prepared on Linux for 1 month, but on my own. But I haven't
Then
done.
yeah, then mostly you are good because so only basics like how to create the files, how to create the folders, how to
Yeah,
copy the file.
exactly.
So these basics are sufficient because
Okay. Okay.
as a DevOps engineer, mostly we are going to work on the Linux platform. Okay.
Okay. Okay. Mm.
So here also we'll have around 1 week classes on Linux basics. Around
Okay.
7 classes we'll have on
Mhm.
Linux basics. No need to bother about the
Okay.
Linux. Even if you don't know
Mm.
Linux, no need to bother. So we'll cover all the
Mm.
basics of Linux, whatever we need to work as a DevOps engineer. Okay, around 7 classes
Okay. Okay.
Linux only. After this, we'll start
Mm.
with our actual DevOps tools. Okay,
Mm.
so here we are going to start with Git. Okay, So what is the purpose of Git? Why we are using this Git? If you want to know, so you already have idea on SDLC, right? So in SDLC,
Yes.
what are the different phases we are going to have? So we will have planning
We have
phase.
planning phase,
Okay, so development
then
phase. Okay,
design. Yeah.
yeah, planning,
Design develop.
the design, planning, everything will come in one phase. Okay, so once our design
Yeah.
and planning is ready, our development team will come into action. Development team will do the development of the code. Okay, so the
And then
phase is development of the code. Then once our code is
testing of the
available,
code.
we are going to just, I'm calling as a build. Okay, it's build
Yeah.
phase. So in the build phase, we are going to compile the code, we are going to test the code, we are going to generate the artifacts. Different stages will be there under build phase. Okay.
Yeah.
So once build is success, we are going to deploy our code.
Deploy.
Deploy. So these are the phases we are going to have in any SDLC model. So we have different SDLC models, like waterfall model and agile methodology. So whatever the model we are using, so every model will have these are the main phases.
Yes.
Okay. Now, so planning and design, it is not our part. No need to bother about the planning of the project, design of the project. Architects will take care of it. Okay. And then
Yes.
development of the code. So who is going to develop the code?
The
For our project.
developers.
Yeah, developers. There will be developers. Developers are going to develop the code. But here, what the developers will do is they will develop the code. Let us consider we are working on Agile methodology, Agile SDLC model. Okay, so in Agile SDLC model, the development team is going to work on the sprint basis.
Yes, small increments.
Yes, yes. So sprint basis. So sprint is nothing but 2 weeks or 10 working days. Every 2 weeks we are calling as a one sprint. So at the end of every sprint, let us consider sprint one completed for our project. Okay. At the end of a sprint one, our developers are going to release version one. Okay. And at sprint two, so we'll get version two code from our development team. So like this, different versions of the code we are going to get from the development team. Okay.
Yes.
So now we have to maintain all these versions of the code. Okay, we have to maintain all these versions of the code. So maintenance of the code is our part. Okay, as a DevOps engineer, we have to maintain the code from the development team. We are not going to write any code, just we are going to maintain the code. How to maintain the code? So to maintain the code, we are going to use version control systems. Okay, so here what we are getting from the development team, different versions, version
Different
one, version,
versions.
okay, different versions we are getting now. So we are going to use version control system. Okay, so to maintain the code from the development team. Okay, from our development team, to maintain the code, we are using version controls. So Git is one of the popular version controls. We have some other version control systems also, but Git is one of the popular version control system.
Version.
With the help of the Git, we are going to maintain the different versions of the code from our development team. So that is the purpose we are learning Git. Okay, so it is clear, right? Why we are learning Git. Okay, so as a DevOps engineer, we have to maintain the code from our development team. So we are using Git and GitHub to maintain code. Okay. So we'll see how can we maintain. Okay. So here we are going to create the branches. So like feature branches we are going to create, and hotfix branches, release branches we are going to create, and so we'll see how to merge one branch and other branch, because in real time we will have different development teams. Many development teams will be there. Okay. So we'll get the request from the development team to merge their code into the master branch. Like that request we are going to get. How to handle all these requests, we'll see in the Git. Okay, so we'll start from the basics for Git also. and we'll learn the advanced topics from the Git, like Git cherry pick and Git mesh. Okay, so Git revert.
Yes.
So all these things we'll discuss in the Git. Okay, now, so by using the Git, what we are doing is we are going to maintain the code from the development team, and once our code is ready, okay, so here is under dev phase, development of code, the code phase, we are using Git. Okay, now once the code is ready, what we have to do, we have to build the code. Okay, where our code is ready, our code is available under version control system. Okay, so once the code is ready, we are going to build the code. Under build phase, what we are going to do is we are going to compile the code. Okay, and we'll validate the test cases.
Test cases.
Okay, we'll package the code. Package the code. The combination of all these stages we are calling as the build phase. Okay.
Build phase. Yeah.
Similarly, what we will do is we'll add quality checks also. We'll do code quality checks also. Code quality checks. Okay, so these operations we are going to perform. So once our code is ready on version control system, so we are going to pull the code to perform these operations.
Operations.
Okay, so to perform these operations, we are going to use CI/CD tools. We are calling the tool which will perform compilation, testing, code quality checks, packaging. The tool we are calling as a CI/CD tool. So Jenkins is one of the popular
CI/CD tool.
Okay, so what this CI/CD tool will do? So it will get the code from version control system and it will perform these operations. It will compile the code, test the code, do the quality checks, and it will do the packaging. These operations will be done by the Jenkins.
Jenkins.
So Jenkins is a CI/CD. Okay, so what is CI/CD? We'll discuss in the coming sessions. Okay. So with the help of the Jenkins, we are going to build the code. Okay. And here we are going to create different types of projects with the help of the Jenkins. So we'll create a freestyle project. A freestyle project we'll create, and we'll see how to create the pipeline project, the CI/CD pipelines, how to create CI/CD pipelines. CI/CD pipelines, how to create, we'll see. And we'll create Maven projects. Okay, so like that, different types of projects we are going to create when we start with the Jenkins. Okay, so here what this Jenkins will do is Jenkins will perform the build operation. So to perform the build operation, this Jenkins will take the help of other tools also. So Jenkins cannot perform any activity by its own. Okay, so what this CI/CD will do is it will just manage the activities. But actual work will be done by other tools. So under build phase, what we are doing? We are compiling the code. We are validating the test cases. Okay, so to perform these operations, so Jenkins will take the help of build automation tool like Maven. Okay, so we are going to discuss about the Maven also when we are discussing the Jenkins. Okay, along the Jenkins, we are going to discuss about the Maven. So Maven is also one of the popular build automation tool. Is a build
automation tool.
What this Maven will do? It will perform the compilation, testing, and packaging. These operations will be done by the Maven. But what the Jenkins is doing is it is going to trigger Maven. Jenkins will trigger the Maven. Okay, Jenkins will tell what operation Maven has to do. Okay, so whether Maven has to perform the compilation, or whether Maven has to perform the testing, or whether Maven has to perform packaging, these instructions will be given by the Jenkins. Okay. Now, similarly, we have code quality checks. So code quality checks, to perform this code quality checks also, Jenkins will take the help of other tools like Sonar, SonarQube. What is this SonarQube means? So SonarQube is a code quality checks tool. This is one of the popular tool we are using to check the quality of the code. Okay, so by using this SonarQube, so Jenkins will check the code quality. Okay, so check the code quality. So we are going to integrate Jenkins with Maven, and we'll integrate Jenkins with SonarQube, and the SonarQube will do the code quality checks. If our code, okay, what is the code we are getting from our version control system? Okay, this code meets the requirement, then only the build will be success. Okay, if the code quality doesn't meet the requirement, then build is going to fail. Build will fail. Okay, similarly, here Maven is doing compilation, testing, packaging. Okay, so if we face any issue with the compilation, then Jenkins build will fail. If we face any issue with the testing, then Jenkins build will fail. Yes, we'll see. So how, if the Jenkins build failed, how to rectify these things? All these things we'll see in the coming. Okay, is it clear up to now?
Yes.
Okay, so the reason why we are learning Jenkins is to create the CI/CD pipelines. So this CI/CD pipeline we can automate. Okay, to complete the build operations. So once we done with the build, means our CI/CD build is success. Jenkins build is successfully completed. Then we are going to get artifacts. Okay. So you have an idea about the artifacts, right? So artifacts are nothing but jar, var, year files, compressed files, which are ready to deploy in our deployment servers. Okay. So the artifacts are jar, var, year files, which are readily available to deploy the code into the deployment servers. Okay. So the next phase is deployment. So now where we are getting the artifacts? We are getting the artifacts from the Jenkins. Okay. So once we got the artifacts from the Jenkins, we have to deploy our artifacts in the deployment servers. So for that purpose, we are using Docker Kubernetes. Okay. So what is the Docker now? So Docker and Kubernetes we can use as a deployment tools to deploy our code. Deploy the code. What are the artifacts we got, right? What is the code we got from Jenkins, right? So after the build operation. So to deploy this code, we are going to use Docker and Kubernetes. So we can use Ansible also for deployment, but nowadays mostly we are using Docker and Kubernetes. Okay. So this Docker and Kubernetes we are calling as the containerization tools. Containerization tools. Okay. So we are calling Docker and Kubernetes as the containerization tools. Why we are calling this as containerization tools means, so this Docker and Kubernetes are going to work on the containers only. Okay. Here we got artifacts, right? So while performing the deployment, we can see two ways of deployment. One is, okay, so under deployment phase, can directly deploy artifacts. What are the artifacts we got from Jenkins? We can directly deploy artifacts. This is one way. Another way is, instead of deploying the artifacts, deploy images into the deployment servers. What is this image? We are going to get this image from the containerization tools. Okay. So this containerization tools, what these containerization tools will do? So containerization tools means Docker and Kubernetes. So here Docker, let us
Yes.
Docker. Okay. So what this containerization tool will do? So it will convert artifacts into images. Okay. So this containerization tool, Docker and Kubernetes, what this will do is these will convert artifacts. From where we are getting these artifacts? From where we are getting these artifacts?
In the build package.
From build phase, we are getting the artifacts. So these artifacts, if you want to deploy, so we can directly deploy the artifacts. Otherwise, we can use images for the
images.
deploy. Okay.
Yes.
Now, so if we directly deploy artifacts, so that is the old way of deployment, so traditional way of deployment. Okay, deploying the artifacts directly into our deployment servers. So that is a traditional way of deployment. So what will happen once we deploy the code? Once we deploy the code, what will happen?
It will go into like a user's
Yeah, it will
live.
our environment will become live.
Yeah.
Okay. Once we deploy our artifacts, our environment will become live. So while deploying the artifacts, so we have two ways now. We can directly deploy the artifacts. Okay, this is the traditional way of deployment. And nowadays, we are deploying the images instead of artifacts. Here, why we are going with images is, so if we deploy artifacts directly, let us consider. So, right, we'll have different types of environments like dev environment, okay, and we'll have QA environment. What will be the other environments we have? We have EAT environment, okay, and prod environment. So like that, we'll have different environments in any organization, right? So we are going to test the code in dev environment, and we'll test the code in UA environment. Then finally we'll test the code in UAT environment. So all testing done, then only we'll move the code into the production environment. This is what going to happen. Now in dev environment, who is going to what? Will be there?
Developers.
Yeah, developers will be there. Dev team will be there in the dev environment. So dev team will develop the code, okay, and they are going to test their code whether the code is working as per the requirement or not. Okay.
Yes.
So let us consider. So our development team released version 1 code. They tested the code in their environment. The testing got success. They are able to successfully release the code. Okay, they are able to test the code without any issues in their environment. So here, just assume for our application to run successfully, JDK11 is required. Just assume. Okay, so JDK11 is prerequisite. Means we have to maintain JDK11 in the environment servers. In dev environment, whatever the servers you are using, that servers need JDK11. Okay, so to make our code success, to run the code successfully, we need JDK11. Okay, now the dev team knows this prerequisite. They will maintain JDK11 in their servers. So that is the reason why they are able to successfully test the code. Okay, so once the code got successfully tested, so there will be dev lead. Dev lead will approve the code to the next environment. Okay, so dev lead will approve the code to the QA environment. So in QA environment, so who is going to test the code?
The QA engineers.
Yeah, QA engineers will be there. QA people will be there. Okay? QA engineers will be there. They are going to test the code. So here, if you see, whatever the version 1 code we have in dev environment, same version of the code will be available in QA environment also. Okay, so and here we are going to get the same version 1 code, version 1 code will be deployed in QA servers. Okay, and now, so let us consider here in the QA environment, there is no JDK 11. They are using JDK 8 something like that. Okay, so what happened to our code? Whether code will
It will not be, it's a fail.
It will be failed. Okay, our code will be failed in the QA environment. But the reason here, if you see, there is no change in the code. Version 1 code only we are testing in QA environment also. But it is going to fail because no JDK level.
We are testing in a different environment.
No JDK level. So this JDK 11 is environment configuration. It is not related to code. Okay, it is a environment configuration. So again, we have to debug the issue. Why the code, what are the version 1 code which got successfully tested in dev environment, why it got failed. Again, we have to debug the issue. Finally, we have to find the root cause for the issue. And after once we found the root cause, then we have to install JDK 11. Again, we have to deploy our code into the QA servers, QA environment. So it will take time. It will take time. Debugging the issue will take time. Okay. Same will be the case in other environments also. PAT and what means. So what I am telling here is, even though we are using the same version of the code, okay, so we have to take care of the environment configuration also to make our code success. Okay, when it is going to happen, if we directly deploy the artifacts, this is the case. Now, so to come the code, to deploy version 1 code into production environment, it will take time. If there is a change in the configuration, let us consider in production environment also, I don't have JDK 11. Then what will happen?
It will fail.
Definitely in production also it is failed. In production, if the code got failed, it is going to affect our business. There will be huge impact. Okay. So this is the case if we directly deploy the artifacts. So instead of this, what nowadays most of the organizations, what they are doing is, instead of deploying the artifacts directly, they are deploying the images. Okay. So how to get these images? To get these images, we are using containerization tools. Okay. So with the help of the containerization tools, what we are doing is, we are going to convert artifacts into images. What are the artifacts we got from build phase? So that artifacts we are going to convert into images. Okay. So these images we are going to deploy. Now, what is an image is, so every image is the combination of application code and other dependencies and prerequisite, whatever the prerequisite and other dependencies we need to run our code successfully. Everything will be embedded in the image. Okay. So now what is the image? Image
Combination of
it is the combination of application code,
the code and the dependencies.
Okay, so plus dependencies, whatever the dependencies we need. Okay, so plus prerequisite is also whatever the prerequisite we have. So everything will be embedded in the single package that is called as the image. Okay, now if we deploy the image in the same way, so let us consider I have the same environments. I am going through the same environments to deploy the images also. Okay, so here for version 1, I'm going to get one image. Okay, so the same image I'm going to deploy in all the environments. Okay, if my image successfully executed, successfully deployed, successfully tested in dev environment. Okay, so irrespective of the environment configuration. Okay, so the same image will be is going to be tested successfully in all the other environments, because no need to bother about the JDK 11. No need to bother about the environment configuration. So this JDK 11 will be embedded in the image itself. Okay, JDK 11 will be embedded in the image itself. So in that case, if we deploy images, if the image got successfully deployed in dev environment, no need to bother about the other environments. We are going to
Yes.
get success build in all the other environment, even though we
Other.
don't have JDK level. So
Mm.
this is one of the good example why we are going with the containerization tools instead of the traditional deployment. Okay.
Okay.
So like this, we have
Yes.
many advantages, many other advantages also with containerization tools. So what these containerization tools will do is it will speed up the production, uh, the duration from a development to the to move the code into the production environment. This duration will be speed up. Okay, so within a less duration, we can move the code to the production environment. Okay, so which will
Yes.
increase the business quality. Okay, that is the reason why most of the organizations are implementing containerization tools. Okay, so we'll
Yes.
discuss how can we use this Docker and Kubernetes to perform all these activities. Docker and Kubernetes perform this deployment. These things we'll discuss. Okay? So these are very important topics. Docker and Kubernetes are very important topics. We'll have around more classes. We'll get more classes on this containerization tools only. Okay?
Yeah.
Because
Okay. Yeah.
most of the requirement is on the containerization tools only from DevOps point of view.
Okay.
So once we're done with this, now you know, right, why we are learning this Docker and Kubernetes.
Yeah. Yes. Yes.
Then we are going to start with the Ansible. So what this Ansible is, Ansible is it's a configuration management tool.
No. Configuration management.
Management tool.
Mm.
So what this will do is it will automate the repetitive operations. So infra related operations. If we have any maintenance related operations, right? So that maintenance related operations, it will automate. Okay.
Oh.
So
Mm.
consider I have 1,000 servers. I want to maintain 1,000 servers. I have 1,000 servers. Okay. Let us consider I have 1,000 servers. On all my 1,000 servers, I want to upgrade my Mongo database. MongoDB, I want to upgrade. Okay. So
Yes.
now, if I want to upgrade my MongoDB on all the 1,000 servers, I have to work manually, right? I have to
Yeah.
manual operation on the 1,000 servers. So if I am going with manual, okay. So let us consider it is taking 30 minutes per server. 30 minutes per server. Then for 1,000 servers, how much time it will take?
Yeah.
So for 1,000 servers, one server 30 minutes, 1,000 servers,
One server is 1,000 servers, so 1,000 into 30.
500 hours.
Yeah.
500 hours. Okay, to complete the 1,000 servers. What we are doing here for 500 hours, just we are upgrading MongoDB.
MongoDB.
Just a version upgrade we are doing. One version to another version, we are doing the upgrade. But how much time we are spending? 500 hours.
500 hours.
It is not going to improve the productivity, right? Okay. Just it
Yes.
is a maintenance activity. Okay.
Mm.
So that is the this is the traditional way of maintenance. Okay. So nowadays, what we are using is instead of doing like this manual activities, we are going to use Ansible. Okay. So Ansible is a configuration management tool. So what this Ansible will do is there will be one controller. There will be one Ansible controller. So this controller is going to be connected with all the 1,000 servers. Okay. Controller will connect all the 1,000 servers. Okay. So now what this controller will do is controller will run the script to upgrade our MongoDB package. Okay. Controller will connect with all the 1,000 servers and it will run the script. So the script will be executed in 30 minutes on all the 1,000 servers. Okay. Now how much time
Yes.
it will take? So within 30 minutes on all the 1,000 servers, in 30 minutes, we are going to perform this activity, MongoDB upgradation. You see, this kind
Yes.
of improvement will be there. So if we are doing manual operation, we have to spend 500 hours. Instead of this, if we go with the Ansible, just 30 minutes. Within 30
30
minutes,
minutes. Mm.
like these activities, will work with the Ansible. So to automate our environment, okay. So we are going to use the Ansible. It is a
Answer it.
configuration
Mm.
management. We'll see. So how can we perform like these activities?
Okay. Mm.
So that is the purpose why we are using Ansible. So then we have Terraform. Any idea on Terraform?
Yeah, it is used to deploy the code or automate the configurations of the cloud.
Yeah, here Terraform also looks like Ansible, but it is completely different.
Different.
Terraform is an infrastructure as a code tool. Okay.
Mm.
So with the Ansible, what we are doing is if we already have infrastructure, okay, we are maintaining the existing infrastructure.
Infrastructure.
But
Mm.
Terraform is not like that. What this Terraform will do
We are
is,
writing a code to form the infrastructure.
yes, we are going to write the code to form the infrastructure.
Form the infrastructure.
Okay. So let us consider I
Yes.
need a 10 servers. Then what I can do, simply I can write one code. If I execute that code, 10 virtual servers will be created. Okay.
Yes.
So I need 5 databases. Then what I have to do, simply I have to run the script. So once I run the script, 5 databases will be virtual databases will be created. Okay, so cloud. So Terraform, if you want to work on the Terraform, we need cloud. On the top of cloud only, we are going to work with the Terraform. Okay.
Yes.
So for that reason, what we are doing is before starting Terraform, we are going to done with the cloud, Amazon Web
AWS.
Services.
Mm.
Okay. So we'll discuss about the Amazon Web Services first, and we'll see how can we create the different services manually. Okay, in the Amazon Web Services. So then we'll try to automate by using the Terraform.
Oh, Terraform.
So in AWS, if you go through the AWS website, right, you can see hundreds of services, but we don't need all the hundreds of services. We need only few services, okay, like EC2 instances,
EC2,
and
auto scaling.
yeah, then we have S3 buckets. Okay, so
Okay.
EBS volumes, okay, and
Mm.
CloudWatch,
Cloud Trail.
yeah, Cloud Train, and so VPC,
Mm.
okay. Then
Yes.
RDS, Relational Database Services, okay.
Yeah.
Still some tools are there, okay. So we'll see around 7 to 10 tools,
Mm.
whatever we need as a DevOps, that is sufficient. Okay. So
Yes.
these tools will try to create manually. The same tools will create with the help of the Terraform also.
Terraform.
Okay. So this is the agenda for our 2 months, and these are the tools we are going to. Any doubts, Apuna?
No, I'm good.
So class duration will be 1 hour, and
Okay.
to do the practice, right, we are not
Mm.
going to install all these packages in our laptop. So whatever the
Okay.
package thing here, right? We are not going to install Linux. We are not going to install Git, Jenkins, Docker, all these things
Mm.
in our laptop. What we are going to do is, first of all, we are going to
Mm.
create the account in AWS.
AWS.
And we will create the account, and from this Amazon Web Services, so we'll try to
Mm.
create one virtual machine. Okay, we'll
Yeah.
the cloud, right? We will create one virtual machine. Okay? So
Mm.
on top of this virtual machine only, we are going to do the practice. So for how to create this account or how to create the virtual machines, these things we'll see in the coming sessions. If you have any
Okay.
doubts, you can ask me.
No, I'm good.
Thank you. Thanks for joining the session.
Yeah. Thank you so much.